بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. My name is Ali Farid Jamil, Senior Lecturer in University of Uttar Pradesh School of Quantitative Science. Today we will present the paper regarding to the HOCOXA 2020 conference, international conference. So the paper, the title is about numerical treatment for solving fuzzy Voltaire integral equation by sixth order Rajkut method. The paper have been The paper first author is Rawa Isa Ibrahim from the University of Mustansiriya in Iraq, Baghdad, and Rasha Hussein from University Al Mustansiriya, also Baghdad, and our PhD student Dulfikar Jawad Hashim. The paper the paper is proposed a new numerical method based by sixth order Rajkut method for solving fuzzy Volterra integral equation of the second kind. As we know, integral equation discovered and used in many numerous logical and numerical mathematical models and appear in many applications in real life problem. When the model under integral equation is imperfect or is incomplete, so its measurement become under uncertainty and under fuzziness. To find the exact solution of this kind of integral equation, it will take a lot of theory, a lot of analytical methods, and for alternative solutions, we can solve it using a numerical method. We can use the linearization and standardization of a numerical method, such as Rajkut methods. The integral equation have been used in application of engineering and biology in fuzzy and encrypted domain, and many numerical methods have been involved to solve these kind of models, such as third order Rajkut method, fourth order Rajkut method, fifth order Rajkut method, Bradford method, Adam Bradford method, and so on. So we suggest in this paper to work on sixth order Rajkut method to find the numerical solution of Volterra integral equation of the second kind directly without special assumption, because the integral equation might be compared to ordinary differential equation and resolved by using any numerical methods such as the Rajkut method. But in this paper, no, we will implement it directly on the Volterra integral equation. This cannot be done unless we modify the sixth order Rajkut method from the crisp case to fuzzy case by using the properties of fuzzy set theory, such as fuzzy number, fuzzy function, fuzzy z extension principle, and so on. Okay. In this paper, in the second section of this paper, we present some basic concept and definition of fuzzy set theory that it will be very useful to modify and to implement our method for solving Volterra integral equation, such as fuzzy triangular fuzzy set number and also trapezoidal fuzzy number. And the solution is not correct if it will not take the shape and the form of triangular fuzzy number or trapezoidal fuzzy number. Uh, if not, there's a mistake in our theory, there's a mistake in our modification. So to validate our method that follow the fuzzy set theory, the solution was in the form of fuzzy number, and we have the definitions also of fuzzy integrals. We can see fuzzy integrals taking the lower and upper bound of fuzzy solutions to follow the fuzzy number properties. And this is the general definition of fuzzy Volterra integral equation of the second kind. And this is the fuzzy, and this is the and this is the fuzzy differential. Fuzzy Volterra integral equation, and this is the fuzzification. The fuzzification is under the crisp domain, but more generalization. So the process of fuzzy differential equation or any fuzzy topic, it be in the beginning in the crisp, we fuzzify it, then we diversify it in certain methods and the fuzzy properties, and the output also will be crisp. But when the input is crisp and then we process it in falsification and defalsification and the properties of fuzzy set theory, the output it will be crisp under more generalizations of fuzzy set. And here in the fourth section, we present Rajkutta method, 6 other Rajkutta method. The Rajkutta method have been modified and have been developed under fuzzy set theory properties, and we modified in details to be suitable for solving fuzzy Voltaire integral equation directly. As I said before, we can transform or convert any certain integral equation, especially linear integral equation, into ordinary differential equation. It would be easy to implement and solve by Rajkutta method, but we want to implement it directly for less computational work and for less time consuming CPU. And this is all the modification under fuzzy number properties or fuzzy set theory properties and definitions. And this is you can see that many the diversification under you can see alpha level set or fuzzy level set, and instead we solve the crisp integral equation one time. We need to solve it in fuzzy set theory multi times, and until it will take the triangular fuzzy number shape or the fuzzy number shape. That's a proof. Fuzziness is generalization of a crisp set, and we have several solutions regarding the fuzzy integral equation to pick which is the best solution from them. So fuzziness is in the other side, we can call it degree of optimality, and we can see the fuzzification process. And after that, we involve a numerical example by giving simple fuzzy integral equations with exact solutions. We can see the exact solutions of under lower bound and upper bound of fuzzy alpha level set, and this is the exact solutions I like here, and this is the value of the fuzzy function here, the fuzzification on the fuzzy function over there. So we defuzzify the integral equations in the lower and upper bound by using the fuzzy number defuzzifications, and we will display absolute error. It's the numerical solution minus the exact solution per each level set. So we need to solve the equation per each level set from 0 to 1. As we can see, we solve it in certain point when x equal 1. This is the numerical solution, and this is the error for the lower bound per each alpha level set. So instead, we solve one integral equation. We will solve here 10, 12 integral equations. After that, if we plot it, it should be taking the trapezoidal fuzzy number form, as we can see. Trapezoidal fuzzy number form, this is a numerical, and this is the exact solution in the blue line, and with only, as we can see, with step size of 10, of 10, we obtain sufficient solution when x equal 1. The error was pretty good regarding to 10 steps only, step size, and this plot proved that our solution is correct and follow the fuzzy number when x equal 1, and the 3D dimension solution is a proof that our solution under sixth order Rajkutta method is satisfy the fuzzy trapezoidal number for all the interval between given interval between 0 and 1, and for all the alpha level set between 0 and 1, and the method has been successfully implemented and defuzzified under fuzzy set theory definition to be suitable to solve fuzzy Volterra integral equation of the second kind. And the numerical example display the comparison between the exact solution and analytical solution and the numerical solution by our proposed method, and the results satisfied the fuzzy set theory and fuzzy number theory. And this method can be modified to solve system of fuzzy Volterra integral equation in future, or Fredholm integral equation in linear and nonlinear form. Thank you for your attention and have a nice day.